Hello everyone. In today's lecture, we have to discuss another concept of the steady state stability, that is nothing but the equivalent reactance and its calculations. In the previous lecture, we had discussed so many concepts of that steady state stability, like the short circuit ratio, that is steady but the saturated reactance क्या रहता है, saturation effect क्या होता है, and synchronous saturation reactance का how to do the calculation of that synchronous saturated reactance. So in this lecture, we will totally discuss the equivalent reactance and its calculation. Okay, so generally the equivalent reactance of that steady state stability, which are generally used in the steady state stability, is generally used to prefer the use the reactance instead of saturated synchronous reactance. Means what? We generally prefer to use the equivalent reactance rather than the saturated synchronous reactance and the excitation voltage, which are generally vary with the load. Thus, the reactance and the EMF, which are generally constant during the small change in the load, even their values should be depend upon the initial operating condition. Such quantities are generally called as equivalent synchronous reactance or the equivalent excitation voltage. So while using the synchronous reactance, we generally prefer to use the equivalent synchronous reactance and the equivalent excitation voltage, which are generally vary with a small change in load, which generally depend upon the initial operating condition, not depend upon the load, excite reactance and the EMF, which are generally constant. Okay, so that parameter is called as equivalent synchronous reactance and the equivalent excitation voltage. The relation between the voltage and the current of the saturated machine are generally are given by the saturated machine voltage. The relation between voltage is EP is equal to EF upon S, that S is nothing but the saturation factor, minus JXM upon S into the I, that is nothing but the field parameter, and the EP is nothing but that is a Portier voltage excitation current voltage, Portier excitation voltage. And the equivalent unsaturated reactance is what? Unsaturated reactance is equal to except EF dash minus J XM dash into the I, whereas S parameter should be the is not available in the unsaturated condition, where it is available in the saturated condition. Okay, whereas EF dash XM and the XM dash is nothing but a constant one, and generally the S is a function of that EP. EP is nothing but a Portier reactance, Portier excitation voltage. Okay, and the derivative which is observed from the two machine system, and the expression which is equated to finding out the reactance xm dash is nothing but the that is equivalent saturated reactance. The for the saturation machine, we may call it as as EP is equal to EF minus JXM into the I, whereas I, by simplification, we are getting is nothing but I is equal to EF minus SEP upon JXM. So by doing the derivative, that is into the rate of change with respect to the EP, that is di by dp di by dep is equal to minus JXM multiply by small change in is nothing but the DSEP upon DEP. For the equivalent unsaturated reactance, as we shown in the equation number, that is a 42, that is I is equal to EF dash minus EP upon JXM. So from this equation we are able to find out the I for the unsaturated reactors. So इसका value अपन directly यहाँ पे put कर सकते हैं. So thus we are getting the di by dep is equal to uh, minus of I upon JXM dash. So by equate the equation number 43 and the 44, we are getting to solve for the XM dash. So XM dash के लिए अपन solve किया, तो we are getting the value of that equivalent synchronous reactance under the steady state condition, under the saturated condition. So the equivalent synchronous reactance is nothing but the XEQ is equal to XP plus XM dash is equal to XP plus XT minus XP, small change in EP with respect to the small change in the S into the EP. That is the equivalent synchronous reactance. Okay, so the real derivative, that is nothing but DEP upon DSEP, is called as slope of the no load saturation curve if it is regarded to the plot of the EP against ESP. So thus the consider the equivalent reactance given by that equation is nothing but in the complex parameter. Okay, so in the simple word, the resistance component is generally neglected. The resistance component that is ready, but the what are the different that is XP should be the um, resistance component neglected. However, the magnitude of the derivative in B lies with the two extreme of that A and C. Thus, the equivalent synchronous reactance uh, lies between the extremes of that. That is in the two range XQ equivalent minimum is equal to XP plus XT minus XP is the slope of no load saturation curve upon slope of air gap line, and EQ is equal to equivalent reactance maximum is equal to xp plus xt minus xp upon x. This is nothing but all about the mathematical calculations to finding out the equivalent reactance of that synchronous machine by using this derivative or by using this mathematical derivations. Okay, so in next lecture we'll discuss the another concept, another methods to finding out the equivalent reactance, that is nothing but the graphical determination of that equivalent reactance. Thank you so much.